So this example is again asking me to find a Maclaurin series, but there's no substitution happening here because this is still cosine of x. So this manipulation just means take cosine of x and multiply every term by x. Again, first four non-zero and the general term. So let's write out what we're doing here. We're going to use the cosine of x expansion and multiply. Remember, that's one of the manipulations that we can use. So we're going to multiply each term by x. So let's start by writing out the cosine of x expansion. So cosine of x is even, so it starts with 1. Then it alternates sign, so x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. That's the first 4. Now the general term, x to the 2n over 2n factorial. Make sure you put parentheses around that. I'm supposed to manipulate this. So again, I'm not going to build this from scratch, which I'm capable of doing. I'm going to use cosine and multiply each term by x, and that will give me my new expansion. So I'm going to take x cosine of x is going to be x minus, multiply each term by x. So this is x cubed over 2 factorial, x to the 5th over 4 factorial, x to the 7th over 6 factorial. So I did not change the factorial. It is still alternating in sign. All I did, I have x to the 2n, and I'm multiplying times x. So remember, you're supposed to add those powers together. So this is x to the 2n plus 1 over 2n factorial. That is the first 4 non-zero terms and the general term. Now, this next one is asking me to find the integral. This is kind of interesting, from 0 to x. So it's a definite integral of sorts, but the answer is not going to be numeric, right? Because I'm evaluating to a variable. So my answer should be in terms of x. So let's kind of address that. Okay, so I am going to, again, first 4 general term, right? Oh, y'all, do I know how to integrate this? I do, but it requires integration by parts. So I could use integration by parts and then build this series from scratch, but I don't want to do that. Why would I do that? That's why it's telling me to use the answer to part A. So again, I'm going to integrate from 0 to x, right? F of t dt. All this means is that I'm going to change the variable to t because these variables cannot be the same. So I'm going to rewrite the f of x expansion with t's, right? So this should all have t's in it. So let me start with t cosine t. And then I'm going to write out the expansion. So t minus t cubed over 2 factorial plus t to the 5th over 4 factorial minus t to the 7th over 6 factorial. General term, negative 1 to the n, t to the 2n plus 1 over 2n factorial. So there's a dt here, right? That's what I'm being asked to integrate from 0 to x specifically. So let's integrate this. So I'm going to integrate by adding 1, so t squared over 2. And then you add 1, divide by that same number or multiply by the reciprocal. Don't forget to keep the factorial though. T to the 6th over 6 times 4 factorial. T to the 8th over 8 times 6 factorial. Plus, so this is, you add 1, right? So t to the 2n plus 2 over that same value, 2n plus 2, times the 2n factorial. But we are evaluating from 0 to x. Now I know that that seems daunting. Like, wait, what? But we're about to plug in a 0 everywhere that there's a t, which means all of that is going to collapse. So my only responsibility when I write this is to take an x and plug it in everywhere there is a t, which is what I wanted anyway, because I want my final answer to be in terms of x's. So now my answer is x squared over 2. Can I reduce this to 8? Sure. Do I need to? Nope. I could do 6 times 24, but I don't need to. It's not necessary. So I'm going to leave this in this pattern because that's how I write the general term anyway. So that way I can see the pattern a little more clearly. And I just want to re-emphasize as I'm writing this that while this does seem like redundant, like, oh my gosh, I got to write all this again with just an x in it. It's way better than having to build this using IBP. So if you're going to make me write one extra step with x's in it, I'll take that. That's way better than having to use integration by parts to try to figure out what this integral is with the Maclaurin series. Okay, so this is my first 4 terms and my general term of the integral of f of t from 0 to x. Right? So this is what we used and we integrated. So we've done a few manipulations at this point. We've done a substituting, right? So we substituted here. We did a derivative. We also did a multiplying one right here. And then we did an integral. So there's a few of these that we didn't do, right? We didn't do an adding or subtracting. We didn't do a dividing. But we've kind of hit the highlights of what some of these manipulations can look like.